Hello and welcome to another session in my Data Preparation for Data Science webinar. My name is Gerhard and I'm a book author and data scientist at SAS. Today we are going to focus on data quality for analytics, and I will show you how you can detect systematic missing values in your cross-sectional data. In this session we will focus on two things. First, we will take a look how you can get insight about the nature of your missing values. Are they random or are they systematic? And then we will also take a look on how you can detect pattern and profiles in your data about the missing value structure. It is important to understand whether the missing values in your data are missing rather randomly or systematically, because this has an effect on the imputation methods that you can choose, on the predictive model that you build afterwards, and what is the understanding, what is the business process behind the data. Maybe there's some hidden pattern that you would like to know and understand before you build the model. Let's have a look at the data here in SAS Visual Analytics. You see in the table view that I have some variables, for example the income variable or the job class variable, which contains missing values. I would like to find out a little bit more about that, about the frequency and about the structure. What I can do, I can simply add a cross tab here from the objects and say that I would like to understand better the frequencies of job class, and you see that I have here, when I show this in absolute and relative numbers, that I have missing values in 665% of the cases, 665 cases, which is rather 6.5%. And if I add here also the totals, I see that in total we have 10,300 observations. So we see something around 6.5% missing of variable job class. In our exercise, however, we would like to understand better, do these occurrences of missing values rather recur randomly, or do they have relationships with other variables in the data? In order to do so, to analyze this, we create an additional variable. This additional variable is a calculated item where we say we call this job class missing value indicator. So this indicator should be yes if job class is missing, or no if job class is not missing. In order to do so, we can browse here for different functions. As an operator we take an if then else clause, and we also add here the query whether this is missing or not. And now we take our variable, which we say the job class, add the job class here and say if it is missing it should be 1, otherwise it should be 0, and we quickly format this variable to have just integer numbers. So what we receive here is, we can preview this, a variable if it is missing job class it is 1, otherwise it's 0. This is what we want, and we say OK. We now say this variable should be a categorical variable because we would like to explain it and analyze it, and we do so by adding a decision tree into our analysis. In order to add a decision tree to our analysis, we create a new page, and in the objects we see, if we scroll down, we do not only have graphs and visual objects, but also analytical objects like a decision tree. Add the decision tree here, and we now say as a response variable, please use the job class missing value indicator that we just created, and we add now certain predictors to this decision tree. So we would like to explain whether job class has a missing value or not on other variables. And for example, let's take some variable like the age of the customer, the blue book value, the claim amount, the claim frequency, the home value, and whether the kids are still living at home. And from the categorical variables, let's take, for example, variables like married, gender, density, does he have a claim flag, the car use, and the car type. You just pick some variable, or you could also use all variables. As soon as we say OK, Visual Analytics builds a decision tree to explain the occurrence of a car type yes, no, and we see that it could build a decision tree with certain splits. And we can also investigate here by looking, for example, at the ROC chart. Is this rather a random model, or is this rather a meaningful model? And we see from the ROC statistic and from the ROC chart that this model is one which explains quite well whether job class is missing or not. So we can infer from that there's quite a relationship of our input variables, especially car type, the home value, the car usage, claim frequency, and others, on the outcome of whether it's a systematic value, yes or no. We can also see this from our different splits. We see that the decision tree could split it down to certain groups where the occurrence of missing values is quite high. For example, here in this group or in this group in certain areas, and is quite low in others. From this we can infer that the occurrence of is job class missing rather randomly or systematically, it will be rather systematically. And we see that this can be very easily and very quickly be done with a decision tree in SAS Visual Analytics. If we take a more detailed look on the tree, we see that the first split was done on car type. So we see on average we had our 6.5% of missing values occurring for job class. However, when we split it into certain groups, for example, panel trucks, pickups, or vans, then the job class is missing much more frequently, in 70% of the cases instead of 6.4%, whereas with other car types, it's only happening at 0.8%. So we can derive from that there's potentially quite a strong relationship between what is the car type the people are driving and whether their job class is available in the data or not. So maybe there is some business relation, some business explanation for that. And there is another method in SAS Visual Analytics which you can use to explain the values of certain variables. You can go to data and again use our job class missing value indicator variable that we just created. Do a right mouse button on that and choose explain. And we would like to explain it on a new page. And this triggers an automatic analysis which runs to see how can we explain the value 1, for example, of the job class missing value indicator. What of all the variables in the data which are now considered are highly related to that. Again, we see, for example, our variable car type here, where we see for certain car types like panel trucks, pickups, and vans, the relative proportion is higher. But we also see other variables like the maximum education. We see that the missing values of job class mostly occur for those with a master's degree or for those with a PhD degree. So we see from this analysis we can find out what variables are highly related to the effect systematic, potential systematic missing of job class, and from these variables that have a high relationship, what are the different values, the different distributions which have high or low missing values in job class. In order to show that this method works very well to detect the nature of missing values, whether it's systematic or random, let's take a look at another variable. I've created here a variable which I called random missing value indicator 10%. This is just a random assignment to ones in 10% of the cases that I created. If we now go and try to predict this variable, or try to explain this variable with the same method as we used before with the decision tree, we see what the outcome is going to look like. Let's go and duplicate this page. This is our decision tree that we created earlier for our missing value indicator for job class, and go and replace this for the random missing value indicator that we just created. If our assumption is right that this method works well, the tree for a random variable should look rather sparse, and almost no meaningful splits should be able to be made here. And this is also what we get here. We see that different from our earlier tree, the tree is quite small. It can almost not explain anything really nicely. It only could split a very small group of missing age variables, which might be related just by chance randomly to that outcome. And we also see that the ROC curve is almost flat and does not exhibit any nice pattern. So compared to the one where we had quite a relationship behind the data and one which we run on random data, we see quite a difference, which we can interpret as a good indicator that the method to create missing value indicators and try to explain them with decision trees or with automatic explanations works very well for your analysis. After we have seen how you can get insight into the nature of missing values with decision trees or with automatic explanations in SAS Visual Analytics, let's now take a look how you can use a SAS macro to get an overall picture about the missing value structure in your data. I have opened SAS Studio here, and I have loaded the macro missing value profiling that I wrote in order to profile the structure and the co-occurrence of missing values. If I now load this macro to my SAS session, I can in the next step go and use this macro on my analysis data. Here I'm using the HAVQ dataset, which is quite famous and frequently used in SAS. It deals with data from credit lines and the fact whether the credit line is bad, or what the job of the applicant is, how many credit lines he has, what the age of the oldest credit line is, and so on. If I now run this macro, we will receive some insight into the missing value structure of our data. The first output that we receive is a frequency report of the missing value profiles. And the missing value profiles are concatenations of ones and zeros for all the variables that we want to use in the analysis. Here, digit 1 is bad, digit 2 is the link variable, which is the number of bad credit lines of the customer, and so on. So if a customer record now has no missing values at all, we would expect, or we will get a value chain like this one. It says all of them are zeros, meaning this is a pattern where none of the analysis variables are missing. And we see this occurs in 4,900 cases in our data, which is 82% in relative values. This means that we have full records of our data with no missing values for any of the variables in 83% of the cases. Then the next most frequent pattern is a pattern where we have one missing variable, namely for the third variable, for the DEROC variable, which is which would indicate the number of bad bad reports on the customer. So we see in 3% of the cases we have a missing value in this variable, but no missing value in the other variables. And then we have another pattern showing that we have missing values for the second, the third, and the fourth variable, for these variables, So in 2.5% of the cases, missing values occur together for these variables. So this report that we receive here gives us insight in the structure of the missing value, and we can learn from that whether maybe there are some patterns, some co-occurrences of missings, which we would like to know for the analysis before we start to run it. We also get a visual display of the frequency of the pattern as we see them. Again, the very big field here is the case where we do not have missing values at all, full records. We have a field that we already mentioned here with the missing value for the third variable. And for example, we also see that we have quite a large proportion of missing values for all variables except the bad variable. This indicates that there is a certain amount of variables in our data, a certain amount of records in our data where we only know the outcome, bad, yes or no, but we do not have values for any of the input variables. It's a question which the data scientist has to answer here, whether he should use these records at all for the analysis, because if he would impute it, he would just get artificial values into the analysis data, and maybe it's even better to remove this set of records and observations of the customers. What we also receive with the macro is an output that shows us the univariate frequencies which you usually get in any other missing value analysis as well. But you also get an explanatory analysis about the potential co-occurrences of the missing values. I'm using here variable clustering and principal component analysis on the missing value indicators of the various variables. I agree that I'm a little bit misusing these methods, which are basically not intended to be used on binary indicators, but as we consider this here as an explanatory analysis, we would just like to get some insight. Do missing value occurrences for certain variables occur quite often together or not? And we see both from the variable clustering tree diagram that certain variables, for example, the number of credit lines, the job, and the age of the oldest credit line occur with the missing values quite often together, and maybe this is a structure which the data scientist should know or should discuss with the business experts, why these missing values occur so frequently together. So it indicates also here in the principal components output plot whether we have certain groups of variables where missing values occur quite often together, and we have a trigger to discuss this co-occurrences with business people in order to better understand our data before we start the analysis. In this webinar, we have focused on missing values, and we especially have taken a look on the occurrence. Are they rather occurring randomly or systematically? I've shown you a very easy method in SAS Visual Analytics how you can use just a few mouse clicks to get an answer about the occurrence patterns. And I've shown you a SAS macro, which you can use to get more insight into the structure and the co-occurrence of your missing values. My focus here is to create an awareness how important it is to include the analytic considerations already very early in the data preparation and in the data quality process. And this is what I've also focused in my SAS book, Data Quality for Analytics. Thanks a lot for joining. In this webinar, we have focused on data quality for analytics. However, in my data preparation for data science webinar series, we will also speak on other topics like how to assemble the data and how to use them directly for analytical models, for example with feature generation. In my webinars in general, I'm focusing on how to bring the things together, which are important in data preparation, in data quality, and in how you can apply them in data science use cases. This is what I've also done in my SAS Press Books, which you can see here. I look forward to see you soon, and there's more content on these topics on articles and blogs that I publish on Medium and on LinkedIn. I do regular webinars in the SAS channel on YouTube. I publish articles on SAS communities where I show some macros and tips and tricks, and all the content that I'm showing here can be downloaded from my GitHub page. Thanks for joining. Look forward to talk to you soon.